All right, everybody, here's day 2, some more examples from 7.2, which is on verifying trig identities. So we're going to go through and try a few more practice problems and see how our different strategies of substituting, changing everything into sine and cosine, do order of operations, factor, distribute, all of those different things that might make this a little bit easier to deal with and be able to verify that they are, in fact, representing the same values. Remember, the difference in verifying is this equal sign. We have a statement of equality. We're trying to show that these two things are equal. All right, so let's take a look. The one side doesn't have a lot going on, so I think we're going to have to primarily work with this right-hand side here. So I'm going to leave tangent as is for right now and see what I can do on the other side. So again, just like the day 1, if you want to pause the video as you go and just kind of try it and then check in and see if you did something similar. And again, there's lots of different ways to do this. We have lots of different choices as we see things. So there's some kind of cool ways to look at this. So let's start with just one option anyway. So we could change over everything over here on the right into sine and cosine. So we already have those. Cotangent squared would be cosine squared over sine squared. So we have everything in sine and cosine. Then again, over here on the right, it looks like we can do some simplifying. So we would have just sine to the first down there. So numerator is cosine over then cosine squared over sine. And again, on the other side, we still just have tangent of x. Then let's keep going, see what we can do. This is division, so we need to do our dividing. So cosine over 1, always a good idea, times the reciprocal. So it'd be sine over cosine squared. And again, that would be equal to tangent of x. And then let's see what we have here. We can reduce one of the cosines, and we're left with sine over cosine, which is for sure tangent, so we just need our statement of equality. So we can either change over sine over cosine for tangent, or some people like to make it as easy as possible, so tangent equals tangent. We have verified that identity. So remember, it doesn't have to be easy, it just has to be equal. Words to live by here, but you can write it either way. So that's one option. So changing everything to sine and cosine works great. Another thing that you might see to be able to look at this is right from the beginning, this cosine over sine. Cosine over sine is the same as cotangent. So that side of the equation could have been cotangent over cotangent squared, which would have been, if we reduce 1 over cotangent, which would have been tangent of x right away. So if you recognize that and see that right away, that ratio, man, that's a lot shorter, a lot less arithmetic, but they both work. So that sine and cosine is sort of your kind of go-to backup plan. But if you see something else first like that, fantastic. You have another option of a way you could solve it. Okay, let's try another one. So here's another situation very similar to the last one. See if we can work on each of these sides here. Again, cotangent, probably not a big issue to deal with. See what you would start with on the other side. So go ahead, pause the video if you'd like to, and then you can give her a try. All right, so what I'm looking at down here is I see this 1 minus cosine squared. For me, my first choice then would probably be to put in sine squared. All right, so we have sine squared of x. So cotangent would be equal to, now we can reduce. So we end up with cosine over sine. And again, cosine over sine, that would give us our cotangent. So this one simplifies down pretty easily. Just trying to have you see and recognize right away that sometimes making those simple substitutions, those Pythagorean ones, really make a difference. Okay, let's take a look at the next one. So again, we have one side that's far more involved than the other, and I would look, whenever you see those squared things, this is to really try to help you do some of those substitutions. Look for those things that we can substitute for. So on the left-hand side here, 1 plus tangent squared, that's the same as secant squared. And I'm just going to leave this for now. And then probably going to need to do some more substitutions. That was a Pythagorean one. I think because the other side is a sine squared, it might make sense to look at this left-hand side and change everything into sine and cosine. So if it's tangent squared, that would be sine squared over cosine squared. Secant squared is 1 over cosine squared. And we're trying to prove that that's sine squared of x. All right, now let's see if that's true. So we have a division, right? We have our big fraction bar, so that means divide. So we're going to multiply by the reciprocal. Some of you will recognize right now what's going to happen with that simplifying. Those cosine squared terms will be able to divide out, but some people like to see it as the multiply by the reciprocal. We're trying to prove, again, keep your equality going here. This is identity. It's an equation. So if you're working with an equation, you need to keep it all the way through. But we can definitely divide out those cosine squareds, and we have sine squared equal to sine squared. So it works really well. We can get that identity verified. I'm going to go ahead and finish up the last couple examples here so we can talk about those. Gets into a little bit more kind of simplifying and working through the arithmetic. Gets a little bit more involved. I don't know what that minus thing is there. It's not supposed to be there. So we can talk through a couple more, and then I'll get you a chance to practice a little bit more. So let's take a peek on, obviously, the left-hand side. It's a lot more complicated. We can work with that numerator and denominator. Again, lots of different ways to do this. So let's change. It looks like everything's in sine and cosine except for the tangent. So I think I'm going to change that over. So sine times cosine over 1, and then that's all over sine squared. And we're going to try to prove that that's equal to tangent of x. Okay, so now I have everything in terms of sine and cosine. Now going from there, I'm going to have to do some work here to get a common denominator. A lot of people get stuck here like, I don't know what to do. Remember, you just have to do the operation. So in the numerator of this big fraction, I see a subtraction. I'm going to have to do that subtraction. In order to subtract, I need to get a common denominator. So it looks like that'll be cosine. So I'm going to multiply top and bottom of that fraction by cosine. So that's going to give me sine minus sine times cosine times cosine. That would be sine times cosine squared all over cosine of x. And then big fraction bar, and then we have our sine squared of x on the bottom, and that's equivalent still to tangent of x. So all I did was just get that common denominator. Now looking up in that numerator, I have to try to see if I can do anything with that. So looking just at this numerator right here, see if we have any ideas. What could we do? Well, it's kind of like writing this statement, right? Y minus y times x squared. If that was your algebra sentence, what would you do with it? I would probably pull out the y. So in that case, I would pull out the sine of x. And that's going to leave a 1 minus cosine squared of x in the numerator. That's all over cosine of x, which is all over sine squared of x. All right, so we made some progress. I think this is going to help us because look inside. Remember when you factor, when you pull out a GCF, you always want to look and see if you can factor it further. Once we pull out that sine of x, we see that we have something that's a Pythagorean identity. 1 minus cosine squared, that's sine squared. So we have sine of x. I'm probably showing a little bit more work than some of you would. I'm going to replace 1 minus cosine squared with sine squared over cosine of x, and then all over sine squared of x. So many different ways that you can proceed in terms of simplifying here, but I'm just going to kind of go the long way. All right, so when I look at that, I have sine to the first times sine squared. That would be sine to the third over cosine, all divided by sine squared of x. And I think we're going to be in really good shape now that we saw that GCF and pulled it out and we're able to substitute, because now we can finally, we have that operation done, we have it simplified all the way down. Now we can multiply by the reciprocal, which think of that as sine squared of x over 1, so it would be 1 over sine squared of x. And now you're actually going to be able to simplify or divide out sine squared, which is going to leave us a sine to the first. So we end up with sine of x over cosine of x, which is most definitely going to be equal to tangent of x. So we've definitely verified that. And that's just one way. There's so many different ways in this that if you would have seen, oh, I could reduce right here, as long as it's mathematically accurate, you're going to be just fine. But we're looking for ways to verify or prove that they're the same. Okay, last example that we're going to do right now for this stuff, and then I think the experience that you get practicing on your own is really going to help. Looking for those substitutions again. So take a peek, pause the video if you need to. What would your first step be? All right, now let's take a look. I'm looking at this, thinking, I bet I can do something with that. 1 plus tangent squared, that is secant squared of x. Don't forget about your Pythagorean identities here. All right, we're trying to prove that this is cosecant squared. So that helps tremendously. I got rid of an operation. Now, you know, we have all different functions, can't actually do it, don't have to factor. So let's do a little bit with with changing things over to sine and cosine. So cotangent would be cosine over sine. Secant squared is 1 over cosine squared. Tangent is sine over cosine. And what I'm trying to prove that this is cosecant squared of x. Okay, so we can simplify this down in the numerator. When we do that multiplication, I can take out one factor of cosine. So I'd be left with, and just be careful as you write this, your numerator would be 1. On the denominator, you have sine of x times cosine of x, and then divided by sine of x over cosine of x. And we're trying to get cosecant squared. That's what we're shooting for here. All right, so we're ready to multiply by the reciprocal. A lot of people lose their numerator there, though, so just be careful when you reduce that down. And we're going to multiply by cosine of x over sine of x. And we're trying to prove cosecant squared of x. All right, well, it looks like our factors of cosine would reduce, and we're left with 1 over sine times sine, so sine squared. And that is indeed cosecant squared. So again, doesn't have to be easy, just has to be equal. So you can decide which one you want to substitute for. But I would probably say cosecant squared. So we've proven that identity. So our job is to make them equal. That's what we're shooting for. All right, so just for you to be able to practice a little bit, I'm going to go ahead and put this assignment up here. So for those of you that would like to get rolling on it so we can talk a little bit more, this is the day 2 assignment for 7-2, page 434. So go ahead and give these a try and see how it works for you so we can get back and start talking about some examples and things that we can do. So we'll talk to you some more about questions once we've given these a try.